Welcome to episode 5 of Generating Conversations. If you are new to the podcast, we're inviting experts in LM technology from research and industry to talk about big ideas and trends that are shaping the field. In previous episodes, we discussed the core ideas in language modeling, when it makes sense to build or buy LM technology, and some of the limitations of generative AI. Today, I'm really excited to have Jerry Liu join us to talk about how to fuse information retrieval with LM technology. Jerry is the creator of Llama Index and one of the thought leaders in how to connect LM technology to your data. He was previously a research scientist at Uber, a machine learning engineer manager at Robust Intelligence, and I tried really hard to recruit him to join my lab at UC Berkeley as a PhD student this year. However, sadly for me, Jerry decided to instead launch the Llama Index startup, where he is now CEO and co-founder. Full disclosure, I was so impressed by his work, I had to invest in his startup even after he turned me down. So welcome, Jerry.
Cool. Awesome. Thanks, Jerry, for being here.
Cool. Maybe, can you tell us a little bit more about your background? I gave a short survey. Are there other things that you would like to highlight?
Yeah, definitely. So I've spent most of my working career at the intersection of AI, machine learning, like engineering, as well as the research side. And also there's some healthy intersection with the startup world. And so it's a very interesting mix because I think my career has kind of taken me through the engineering, research, and startup worlds. For instance, I was doing like machine learning engineering at Quora, so very much working on like practical applications of recommender systems and supervised models, all the way to really diving deep into the fundamentals of stuff like generative models and transformer architectures, and thinking about how to basically make state-of-the-art advancements for self-driving cars during my time at Uber. And then transitioning to the startup world, building an application at an early stage company, especially in the MLOps side, where you're really trying to capture value and sell this to bigger companies. And I think like all of this has been a pretty great combination for really trying to understand different sides of the machine learning space. And the project itself, Llama Index, or it used to be called like GPT Index, probably started relatively spontaneously. But I will say, like, I think a lot of these experiences have helped shape how we think about framing and prioritizing the features to build for this framework as well as the enterprise platform.
That's awesome. Yeah, you have an impressive background. Maybe to inform our audience of the broader context, no pun intended. Maybe you could talk a little bit about kind of how one fuses information with LLM technology. Maybe hint at kind of what this retrieval augmented generation is all about, why we need it, why it's so important.
Yeah, definitely. And so I think there's like two main ways of fusing knowledge into a language model. One is just the classic approach of just training the model on some data set. And, to be honest, I think when starting out, that's probably, especially if you're coming from the ML world, that's like the most intuitive thing to do. And so the parallel for LLMs is being able to actually fine tune or distill a language model on, for instance, like a new corpus of data. If you ask like ChatGPT anything before its knowledge cutoff date, it knows a lot of stuff without actually needing to do any sort of external prompting. There's another paradigm these days called retrieval augmentation, which I would argue has probably been more popular among practitioners, which is this idea of you don't need to actually train a model. You just take like a pre-trained model and figure out clever ways of actually prompting that model so that you can actually feed in relevant context from your knowledge corpus. And so it turns out like a lot of these language models aren't just good at kind of like regurgitating information. They can actually reason over any kind of prompt or information that you give it, and then actually do stuff over that information. Like it could answer questions, like plan out tasks, those types of things. And so that basically is this idea of in-context learning or retrieval augmentation. And that's the primary focus of Llama Index. I think maybe thinking about like the pros and cons of each one, coming from an ML world, honestly, like I still like the idea of like training a model. I think this idea of like black box optimization over your model on some data is very powerful. I think just very practically speaking, these days, people have a hard time setting that up or really understanding how do you actually feed in the right data set and measure performance and make sure that it's, for instance, like actually memorizing the information in the right way. Whereas I think the idea of retrieval augmentation is a lot more intuitive to users because it's really just for anybody building software systems to just like plug and play a few different components together. And so to that end, it is a bit easier to use. And so for that's also why we kind of like started with those principles as a framework.
Yeah, that makes a lot of sense. It's funny, my lab, we're running to kind of a similar tension, but how to mix fine tuning and retrieval in interesting ways. But before I get there, I want to dive a little deeper into the kind of the challenges or in some sense what Llama Index is doing. So if I want to focus just on using retrieval augmentation to improve the knowledge capacity of my model or increase context, what are the challenges I need to address?
Yeah, so I think maybe just in terms of like the high level considerations that you need to think about is basically setting up the right pipeline and system for getting something up and running. These days with frameworks like Llama Index, LangChain, other stuff, it's really not that hard to cobble something that kind of works initially. And so the basic process for listeners that might not be familiar is like you take in some source data, let's say it's unstructured data like a PDF for instance, and then you split it up into like even chunks. You just like split it by paragraphs or by some other separator. And then once you have these chunks, you basically generate an embedding for each chunk of text, and you like throw it into a vector database, right? So that's basically this new like ETL layer for LLM RAG type systems. And then like the next step is when you actually ask a question or have a task, you take the query and basically do vector similarity search and fetch the top K most relevant results or chunks from the vector database. And then you take those chunks and then like stick it into the prompt, and then the input prompt of the language model, and you get back an answer. So that part, if you just like follow a few YouTube tutorials, is really not that hard to set up. I think maybe one of the issues is that people don't really know what to do next after that. So it's like, what exactly, this is going to work for maybe like 40% of the total space of all queries that you might want to ask over your data. Like, how do you actually get to that remaining 60%? And so there's a lot of things that you're going to have to think about. And this includes everything from the initial parsing and chunking to like metadata extraction, so the ETL step into a vector database, to the actual retrieval algorithm, and actually being able to fetch the most relevant information given a user query. And so I think those are probably like the two main components that you would need to think about if you're actually trying to build a performant application. I say once people start moving beyond the initial prototyping phase and think more about like long-term usage, they start taking into account like performance, cost, latency, and also good tools for kind of experimentation, iteration on top of this. And I think having like the right principles for think about how to actually improve your application becomes a lot more important.
Yeah, that makes a lot of sense. Certainly, I've noticed that too. When we think of the hurdles to LM technology, it's often putting these pieces together, and in particular context, managing context, the whole retrieval pipeline, ensuring you have the right retrieve results, and then how you kind of combine those retrieve results. And for those who don't follow Jerry's Twitter feed, I recommend it. He has some really cool insights and how to combine retrieved results. And maybe let's step back. So there in the process, there's retrieval, and there's this kinds of sets of technologies that aid in retrieval. Could you kind of talk through what are those set of technologies and kind of the key steps in them?
Yeah. So, well, if we just take retrieval itself as like a concept, like retrieval itself is not new. I think it just happens to be used in a slightly novel way because now you're kind of feeding this into like a synthesis step with the language model to actually generate like a natural language response. But the goal of retrieval is how do you actually fetch, for instance, like the most relevant information given this task at hand. And so the most basic form, which I just described, is you just like embed the query and fetch stuff via kind of like vector similarity search. And then we think about, okay, like what are things that you can do to kind of one, like what are potential downsides, and then two, like what are things that you can do to kind of like mitigate those downsides. So one downside, for instance, is that semantic search tends to be pretty like low precision. So like if you actually just like for instance, like set the top K to pretty high, you're going to fetch a bunch of context that maybe is relevant to the question at hand, but also a bunch of stuff that isn't relevant. And so if you really want to filter that down, and this is again not a new idea, a lot of users do some sort of like two-stage retrieval pipeline where you first like do some very fast but like imprecise pass to cast to do some initial like first stage filter, and then you do some second stage like re-ranking to actually try to prune the results a bit more and actually pick out the pieces of context that are actually relevant to the user query. And so these days, there's both like old and new re-rankers. There's stuff like cross-encoders, like, like just kind of more computationally more expensive models that you can load in from Hugging Face to actually like filter out the relevant pieces of context that are more relevant to the query. There's also kind of like new re-rankers popping up. Like you can see, for instance, like Cohere has like a re-ranker, which is basically they fine tune like the LLM behind an API, and you can access that as a service. You can also just yourself try using a large language model itself to do some sort of like re-ranking, right? Given the query and given the input context, try to actually do some filtering. Obviously, the downside of any of these steps is it's going to be more powerful, but a lot slower than just like a simple dot product between like two embedding vectors. So that's just one idea. I think re-ranking is a pretty interesting concept. I think the other aspect here is like there's kind of like semantic search. A lot of vector DBs these days have like metadata filtering, and so actually being able to do some like joint querying of both like structured information as well as like combining that with semantic search is generally a very interesting concept. I played around with this like a little bit, and we have some basic components in Llama Index that help with this, but it's kind of like, how do you, like, given a user query that might require access to both structured data and unstructured data, there's SQL for structured data, but there's not really like a good query language that can combine the two. So how do you try to have Retrieval interact with both data sources in interesting ways? And so I think that's something that I was playing around with as well. Going beyond that, and maybe on the query side itself, I think another aspect to think about is that, like, when you think about basic RAG, it's very linear. It's just like, you do retrieval once, the retrieval is some step, and then there's synthesis. But actually, there's kind of like, in my mind, like a spectrum of like, there's like a spectrum from more constrained workflows and more linear workflows to stuff that kind of like can maybe tap into the language model a bit more as a reasoning engine. And so on the naive RAG, you do like retrieval, and then you just pass everything to a language model once to just like synthesize the results. But then like on the other end of the spectrum is like agent-based frameworks or stuff like AutoGPT or anything in like a reactor function calling loop, where you can actually take this question and before you even like do retrieval, try to actually figure out, hey, are there like sub questions or like tools I need to call, like things that I can actually do to like break this task down into smaller steps, do some like query planning, and then like for each individual component, execute that, and then like do retrieval synthesis. And so like, basically, I guess the high-level idea of this is that it's not just necessarily like first retrieval, then synthesis. You can actually interleave the two and do like a loop in interesting ways.
Yeah, it's very cool. Just for our audience, RAG, in case you haven't heard of it, is retrieval augmented generation. It's actually a specific published technique, but it's come to refer to sort of the broader sense of using retrieval, to augment the output of your LLM. Yeah, and your company has been doing some pretty cool work in your team, I guess, on how to mix the LLM and retrieval process to better refine, to re-rank, to use some of that reasoning capability to improve the results. You touched on one more thing that I wanted to talk about briefly before we go to generation, which is working with structured and unstructured data. A lot of the LLM space is very focused on these unstructured textual reasoning tasks, which makes sense. But often people want to ask questions about data that often lives in a database. How does that fit into the whole RAG story and like in Llama Index broadly?
Yeah, so there's a bunch of aspects of here, but maybe just start from the basics. A lot of RAG pipelines, like when we talk about the full pipeline, is really around unstructured data. And so that whole ETL step where you like load in unstructured data, you parse it into a bunch of chunks, and then you load it into a vector database, that's pretty unique to unstructured data. And because like the idea of like text chunking, for instance, is you like split up a bunch of unstructured text into chunks that you then load into like some database. Whereas like I think a lot of what people are exploring LLMs with respect to structured data is like the data already lives in a structured database and like a table. There is already a query language for accessing that table, like SQL. And so the majority of like kind of experiments here have just been trying to play around with like converting like a natural language query into that query language, like a SQL statement they can then execute against a structured database. I think like, the idea of ETL from like any data source into a structured database is obviously not a new idea. There's like the kind of like Airbyte 5 trans, like DBTs of the world, where like you load data from, some data source and then you just like process it into structured data. Maybe one interesting aspect there though is that like I think more people these days are interested in thinking about how can you actually use LLMs to actually kind of automate and enhance that traditional ETL process. And so I kind of think about it as like slightly two different stacks. One, you need like a new ETL stack to actually process like unstructured data. And then the second thing is for existing ETL, maybe you could actually use LLMs to help automate that a bit. Now, like when you actually think about like so let's say the data is like in a unstructured database and then also a structured database, then you think about like how do you actually query this information. And that part, I don't think there's really best practices yet, because I think the field's also evolving and you're starting to see more overlap between the structured databases of the world and also the unstructured databases. Like Pinecone, Weaviate, Quadrant, they all have like metadata filtering. And so that's basically adding like structured annotations to a vector database. And then on the other end, stuff like Postgres, with like PG Vector, they're adding like vector similarity search, and MongoDB has like vector similarity search. So I think in the end, the data systems will probably start to be like a greater overlap between the two. And then from the perspective of like this user or this like agent, if you will, like the thing that's actually executing this query against the data system, its responsibility is to really figure out how can I basically interact with this interface, whether it is SQL or like vector similarity search, to pass in the right queries so that I can actually execute properly against this data system that contains both like semantic search and structured like filtering, for instance, and get back the right response.
Very cool. Yeah. So I agree that we're going to see more kind of convergence of the different data technology stacks as they try to cater to this new kind of use case. So maybe rolling to the high level story, if I'm using LM technology to try to answer a question about my business, I could start the question. We might use the LM to refine my question, perhaps generate sample documents. It might help for retrieval, something like hide. I then use those documents, do a similarity search, perhaps with a vector database, something very fast that returns, let's say, hundreds of little snippets of text. Maybe as you described, you guys have some neat work on this. It also generates some SQL, which pulls some small amounts of table data that then is fed into this now very large context of, probably, hopefully relevant snippets of text and hopefully relevant numbers and data. And I have my question. And so now I guess the next step is the generation. So how do I take all those pieces, put them together and get an answer?
Yeah, so kind of making the assumption that you did the stack that is roughly what you described. So assuming you did have some stack that would like take a query and then you would just route it to every possible data source, whether it is structured or unstructured, get back information from each. And so for instance, for this example, take a query, route it to your SQL database, get back an answer, and then also route it to your vector database, get back like a bunch of context. The next step is now how do I like stuff it into the prompt of the language model? So I think maybe like if you were building this yourself, you would just like dump everything into like the formatted string of this like prompt, and then you send this to the LLM completion endpoint. That would actually probably get you pretty far nowadays with stuff like ChatGPT and Anthropic Claude, especially with the longer context windows. And so stuff like context window limits will probably be less visible until you actually start like stress testing the system by like increasing the K value, fetching even more context, those types of things. So I probably honestly like think about that, just like how much do you need these like kind of outer abstractions to manage away like prompt complexities, and just like start by like sanity checking, like hey, like even just like given like a gold standard like context from your unstructured database as well as like SQL database, can the LLM actually answer the question, right? That's like the first step that you should probably experiment with. Now, assuming the LLM can actually answer this question, then you try to build the entire pipeline around this and see if you can make this more general and robust. So Llama Index does have a pretty cool abstraction, and I would say like this is probably one of the more useful like lower level abstractions in Llama Index that basically anybody can just use to reduce the boilerplate, to basically just abstract away like context window limitations. And so like if you have a context and it's in a bunch of chunks and it overflows the context window, there's like different strategies you can basically do to try to like abstract that away from the user. And so, I'm sure people are still kind of figuring out the best ways to like hack this around the LLM, but like there's basically kind of like two main strategies these days. One is this idea, we call it like tree summarization. I think LangChain calls it map reduce, but like you just split it up into like a bunch of chunks, distribute each call, and so each chunk gets fed to the language model. That chunk will always fit in the context window of the LLM, and then you take the answers across like every sub chunk and then like hierarchically aggregate it together until you get back a single answer. That's like a pretty popular one. You can distribute the calls in parallel too. You can also do it sequentially. So just like given like a context that is like too big, you break it up, and then for each like sub chunk, you just feed it into the LLM and then iteratively refine that answer with more pieces of context. Those are probably the most popular strategies that we've seen today.
Yeah, that's cool. I've run into those, and those strategies are definitely neat. We've in fact started exploring both. Maybe so you hit on the story of context. Maybe pulling all the pieces together. So now I've got these strategies running. Let's say I've chosen to use the MapReduce strategy, which is easier to run quickly at least. I'm making a lot of LLM calls and with long contexts. What might be things I could do, I guess, to shrink the context down further, reduce the costs of doing that?
Yeah, so I think there are strategies these days that I think, to be honest, we're still exploring to basically just like take in a bunch of context and see if you can, you could do some like pre-filtering pass basically with either embeddings or like a cheaper language model to try to strip out stuff that like isn't actually relevant to the query. And so that's a way of kind of like optimizing token usage and actually potentially increasing performance too by just like making sure you only have context that's the most relevant to answer this question. I personally haven't benchmarked it enough to actually see how well this works, but that is one way that you can think about to actually reduce like token usage and cost. The other aspect here is just like, I think honestly, like using different language models, like there's a pretty big gap or like wide variation in terms of like latency cost depending on which language model you use. And so I think maybe it is something that's worth thinking about is like maybe you always start with GPT-4 just a sanity check whether or not things actually work. And I'm using GPT-4 as an example because it's like probably the best model. And then you like go down from there and see if you can actually sacrifice a little bit of performance to actually pick something that is a bit faster and can crunch your tokens better. Like if you can go to like Llama 2 and actually self-host it, right? Like and that actually gives you like a good enough question answering system. Maybe you should choose that because it's also going to be faster.
Very neat. Very neat. So you've been talking about long context. Another aspect of long context that has been a debate for me is, do we really need it? And in some sense, the tricks that you've been developing allow me to work with smaller contexts. And I actually would argue they might be better than trying to use a long context. In fact, some of the early evidence from some of my students is that you can have a long context, but it doesn't mean you read it all. The LMs don't pay uniform attention. So having narrower context and more focused questions might be actually more effective.
Yeah, so if the question, there's maybe like a few pieces of this. Like if the question is kind of about whether small context is better than long context, I do think that's probably true right now. There's a lot of like research that shows that like, yeah, if you like dump in too much unnecessary stuff, then like your performance might actually go down because there's like the whole like idea of being lost in the middle. But I think like maybe the way I think about it is, yeah, so like if you want to optimize for like the current models, like you would probably really try to, this motivates like better retrieval algorithms. So like you don't just do like a wide top K value for your similarity search, actually try to add like a re-ranking module to try to filter down for like a more relevant context and really try to tailor your retrieval algorithm to fetch the most salient pieces that you can actually synthesize a result over. I do think as these language models get better, and there's like kind of an incentive for the model providers to do this better too, they'll just get better at kind of handling long context. Like, yes, like Anthropic Claude can handle like 100K right now, but it probably doesn't handle that super well at the moment. If you like ask it arbitrary questions over that 100K context, might not be able to answer all of it. But with like kind of more training data, with more tuning, it could probably just get better at just being able to synthesize information across these documents. So I don't really I do think like the models themselves will probably get better in that space. But I do think maybe another aspect of this is And I think this touches on one of the points that you made in the beginning, is just like whether people should just like stuff in as much context as possible versus like just doing stuff like fine tuning. Because there also is like a cost aspect to this. Like the more context you stuff in, the higher the cost and also the higher the latency. And so just because you can stuff in like 100K tokens into Anthropic, like doesn't mean you probably should. So then how do you actually think about the trade-offs between, always trying to think about like retrieval one-off generation versus doing something like, oh, maybe you should like try to actually just like update the weights or fine tune like a header or something so that you can get better performance. That part, I honestly don't know yet. The only thing I can say is that I feel like retrieval augmented generation is always something that you should probably start with, just because it's like it's so much easier to get started without having to worry about like data preparation and changing the model and worrying about like degrading model performance, just to see if you can even get something working. And then like fine tuning is always one of those things that if you need like additional performance or you want to reduce cost and latency, you do afterwards.
Yeah, it makes sense. We found similar things, though we did weirdly find that fine tuning worked surprisingly well, to the extent that in many cases we could drop some of the retrieval.
No, I can totally see that. I think maybe the point here is like I do think like maybe just the idea of optimization, like retrieval augmentation is you're kind of just like hacking a software system to around this like module, right? So like, but the problem with hacking a software system is you're not really taking advantage of end-to-end like optimization. Whereas like fine tuning really is this idea of like end-to-end optimization. So I think my argument's more primarily from like a ease of use aspect. It's just easier to get started with like retrieval augmentation.
Yeah, I'll give a little more defense to retrieval augmented generation, because I actually think it's where people should head, even in the long run, is that fine tuning it's hard to reason about what it will do to the model and the kind of long-term consequences. It's hard to retract information. It's hard to control what the model knows when it makes a decision, to get attribution. Whereas retrieval augmented generation, or just using the context intelligently, gives us a lot more control over what the model knows, what it can respond to, what information it has, and it leaves for, at least for our research community, to some time to figure out, should I fine tune my instruct fine tune model, or should I pre fine tune on my new corpus and then instruction fine tune? There's a lot of complexity in the fine tuning space that we still don't understand at all. So yeah, I strongly support what you guys are doing. Maybe it would step way back. So Llama Index is an impressive project. It has a funny name. We should come back to maybe its origin stories and talk through. It's in some sense, I guess, trying to solve many of the complexities in this big design space of how to use context intelligently. Yeah, maybe take us back to the beginning.
So in terms of like the origin story, so first, everybody thinks Llama Index was named after the Llama model, which is very unfortunate because I think I've said this during like a few podcasts again, but I might as well just say it as well, just to establish the truth, which is we came out with the name like a week before the meta model came out, and so we independently came up with the Llama prefix. Before this, it was called GPT Index, and so that's basically how the project started, because the project was kind of just built around exploring the capabilities of GPT-3 and actually trying to augment that with some sort of external knowledge source. And so I think the inspiration for the original thing was just like everybody was playing around with like large language models back then. No one really had like good abstractions for thinking about how do you just dump a bunch of data to GPT and actually get it to understand stuff. And so that really was the motivation. And I was like, obviously there was like embedding based retrieval, and a lot of people started coming with that. I think initially the motivation for this project was just like, could we just have this like hypothetical software system that could use LLMs for both like retrieval and reasoning. So actually the first iteration of this project was like the tree index, which didn't actually use like embeddings at all, right? It was just like a fun thing to do. But I think as like it turns out, like a lot of people were kind of thinking about very similar issues in this space. And so basically what we did was we pivoted this into actually thinking about how do we just build like a really good toolkit for people to connect LLMs with their data, right? And so it would capture like some of the common interaction modes, like for instance, like connecting LLMs with like a vector database, but also kind of have these advanced capabilities of like response synthesis, retrieval, as well as like the initial data ingest and parsing steps. And so that's how the toolkit evolved. And so, started this for fun like last November or so. It's been a very exciting ride. And I think obviously it's like grown pretty quickly. But, we've just been working hard on trying to make the toolkit very good and also very practical for people to use.
Cool. Yeah, maybe we can kind of wrap up by talking a little about the company. So you've launched a company around this very exciting, successful technology. Maybe tell us about where the company's headed.
100%. So I think the company was incorporated in April. We raised $8.5 million from Greylock. The company itself, up until about like a month ago, has been mostly focused on developing the open source community. I think we are thinking and kind of working on like an enterprise version as well. And I think basically the plan for the rest of this year is we absolutely want to still continue supporting the community and growing the open source project, and then in parallel grow the team so that we can start building basically the enterprise platform that is like the next evolution beyond the open source project. And the way to think about these two is we'll have like more details probably with the initial release. But like the open source project consists of like some of the core building blocks for you to build like LLM applications of your data. So doing stuff like you cobble together like a data loader, like a parsing module, like a vector DB, and then you as a developer have a lot of control over like the decisions you want to make. And I think the question is, once you actually start putting this in an enterprise setting, what are some of the challenges that you actually need to solve to make this usable in a production and also organizational setting? So this includes stuff like probably better data connectors that can actually work with higher volumes and also kind of like production needs, for instance, like data refreshing, updating, that type of stuff. This includes stuff like maybe good experimentation tools so that you can really understand how like decisions you make like tie to downstream performance on both the ETL and also the response synthesis side. And this could also include like kind of just like general optimization and deployment things. So like how do you just like make it very easy for anybody to spin up like a server that's deployed in production and just works well out of the box. And so these are all things that we're basically working on.
Well, Jerry, thanks for joining us, and hopefully we'll have a chance to talk more in the future.
Thanks, Jerry.